All right, hey everyone. Today we are looking at section 1.1 notes. We're going to talk about solving one-step equations. So we'll see first here our learning targets for today. At the end here you'll be able to solve one-step equations using addition and subtraction. Also solving one-step equations using multiplication and division. And then we'll look at a couple story problems so you'll be able to set up and solve one-step equations from story problems. So the number one rule of algebra is what you do to one side of an equation, you must do to the other. So you've probably heard this, used this. What it does is creating equivalent expressions. So you haven't changed the problem or the value of anything. It's just how the problem looks. So this basic example I provided here, 6x equals 3x plus 3x. So those are the same, right? Because the 3x would equal to 3x. If I'm going to add 2 to both sides, I haven't changed anything, right? It's now 6x plus 2 and 6x plus 2 on the right side, just the 3x's would combine together. So again, what you do to the one side of the equation, you must do to the other. And that leads us to solving these basic one-step equations, right? So the goal of an algebra problem is to get the variable, so usually x, but any letter, by itself using inverse operations, meaning the opposite one thing of the other. So addition, the inverse of addition, or the opposite of addition, as we know, is subtraction. So if I have this equation here, x plus 7 equals 12, our goal is to get x by itself. So our goal is to get rid of that plus 7. Well, how are we going to do that? We want to do the inverse operation to get rid of it. Now, we just mentioned we want to keep the equations balanced, so we're going to subtract 7 on both sides. We've got our variable alone, and we know 12 minus 7 is 5, so we're done. X equals 5. So looking at a couple other quick one steps, right? If I have x minus 4, well, the opposite or inverse of minus or subtracting is to add. So I'd add 4 to both sides. Again, minus 4 and plus 4, that's 0. That's why that's gone. Now just equals 12, because 8 plus 4, we got x alone. Done. Same thing if you happen to have decimals, and it doesn't matter what side the variable is on, but over here we're trying to get x by itself. So instead of plus 2.1, we need to get rid of it, doing the inverse and subtracting 2.1 over. Sometimes you can put the line if that helps you there underneath. So that'd be what? 2.2 is left, and we got x alone on the right this time. There we are, 2.2. So this is where you could pause the video if you have some scratch paper, seeing if you can just do these addition and subtraction problems, solving for x by yourself, or y here I guess as well. So you could do that now, pause it, but I'm going to go through, see if you got these right. If you did decide to do them, we'd want to subtract 1.3 over, resulting in a difference of 2.1. X is alone. Again, these are just one-step equations, so you only have one thing you're doing each time. Inverse of minus 7 is to add 7 over. Now careful, that's negative 18. So if I'm adding 7 to negative 18, I have negative 11. Lastly, y plus 4, again, doesn't matter what letter you use for the variable. Here they used y, so I want to get rid of plus 4 by subtracting 4, and 23 minus 4 is 19. So not too bad, easy enough, adding and subtracting inverse. Now before we get to multiplication and division, there's a really quick way to be checking your answers. Now these are obviously basic and you probably know you're right away, but as we get into more difficult equations that we're solving, it's important to check it. So if I already solved this, x minus 3 equals 12 here, right? Add 3 to both sides, x equals 15. Well, if x equals 15, you should be able to plug it in for x, like I've done here, and get your original answer. So 15 minus 3 instead of x, because we solved, equals 12. Well, yeah, 15 minus 3 does equal 12, so check. That must be right. So it's easy, takes a couple extra seconds to just check your answers, make sure you're doing them right. All right, so then same thing with multiplication and division, because those are inverse operations or opposites of each other. So for example, if I have x divided by 5 equals 4, well, think about how you'd get rid of division. The inverse is multiplication. So I'd want to multiply by 5 to get rid of the division of 5. And of course, we're keeping things balanced. So I multiply by 5 on both sides. 4 times 5 is 20. Done. Again, you could check that quick. 20 divided by 5 equals 4. Right? And then same thing with the division. This is 4, remember, times y. So if I'm trying to get rid of multiplication, I would need to divide to get rid of that 4. Y is alone then, and 28 divided by 4 is just 7. So again, not too tough still, one-step equations, doing the opposite. This is a good example of it's not always going to equal a nice number. So if I want to get y alone here, again I divide by 3. 25 thirds doesn't reduce to a whole number though, so we do want to be keeping our answers as fractions if they are. So 25 over 3 would just be your answer. Alright, so a couple quick practice ones here. You could pause and do them on your own before I go over these, but I'm going to go over them now. So if we're dividing by 3, we want to multiply by 3 on both sides to get our variable alone. Well, 21, or 7 times 3 is 21. Same thing over here. 8, that's 8 times y. Opposite of multiplication is division, so I would divide by 8 to get y by itself. 40 divided by 8 is 5. So last thing today, looking at a couple story problems trying to set up a one-step equation to solve. So this says John has $19. The sum of his money and Sarah's money is $45. Write and solve an equation to find out how much money Sarah has. So this is easy to think about in your head, but write and solve. So let's just be clear that. So John has $19. We have 19. We don't know what Sarah has. So let's say our variable would be S. We do know what they have total. So it's just 19 plus S equals 45, right? This is John, so if we didn't know, it would be J plus S equals a total of 45. So again, it's a quick solve. You would subtract 19 to see what Sarah has. 45 minus 19, what must be 26. So Sarah has, $26. Again, easy enough to solve, but we're trying to make sure we can set up the equations because again, they're going to get trickier as we go. So one story problem to practice on your own if you want to pause and try it, but Miss Smith gives out 4 pieces of candy per kid in class and ends up giving out a total, again, of 76 candies. Write and solve an equation to figure out how many kids are in class. So if it's 4 pieces per kid or per student, let's call them students, 4S, 4 times each student, right? And she gives out a total of 76. So here we have a one-step multiplication, meaning we need to divide to get our number of students, S, your variable, you can use X, whatever, alone. 76 divided by 4 would be 19. So there's 19 students in class. So setting that up and solving could get you that answer. Making sure for story problems, of course, you're labeling your answers. So in this case, students. All right, so that was it for today, those one-step equations. So on Schoology, you will see one-step equations worksheet that you can work through. Just 8 problems there, some addition, subtraction, multiplication, and division ones, and a story problem or 2. So let me know if you need any help on that. Thanks.